This is the I have opened this. This is ASTO LRFD Bridge Design Specification, 2004th edition, 2007 SI unit. So ASTO has many. After 3 or 4 years, they publish versions. Every 3 or 4 years, they publish a new version, but there are not significant differences in the latest or the previous version. Recently, they have published it. In 2020, the latest version. I don't have that copy, but 99% of the things are similar. So they sometimes remove a section, and in the other version they add that section. So there are no significant differences in these versions. This is an SI unit, and so all the equation in this version are in SI. So bear one thing in mind, that when you work with this version, the formula you use should be you should use compatible units. Otherwise, if you use them for the FPS system, sometimes the student confuse equations. So if you use for them for the FPS system, then you will get incorrect result. I have seen students, they use the SI version and they put values of the FPS system, so it will make problem for you. So as you go through this code, so these are some of the references which also are referred by the code. So these are very good references. You can check them yourself as well. So these are additional material apart from this code. So you can find a lot of things in these material as well.
Aziz, yeah, I cannot see your screen on the full. It's very small. I think it's very small size. I cannot see the full size of your Astro code.
Right. Full size. By full size, what do you mean? A minimized
Your
version?
name, your screen, in your screen, your page. I can see a small, just small window of it. So your name is appearing, but small Astro code is appearing. I cannot see the full. I don't know what's the issue.
Let me ask some other if they are seeing it correctly or not. If this
Yes,
is
it's full screen.
It's full screen with you.
Yes, just click on the screen where you are showing as us or seeing as us.
Okay. So the problem is on Adnan's Adnan side. Am I right?
Yes, sir.
Okay. So sir, you have to click the full screen. Sorry, the small screen. It will pop up. You have I think you have switched the users, so you are seeing the small screen.
I'm not sure because it's not okay. I will rejoin it. I think I will rejoin.
Okay, you rejoin it. If the problem pertains, then we will see what can I do.
Okay.
I think the rest of you guys don't have any problem, don't have such issue. You are seeing my full screen. Am I right, please?
Yes.
Okay. So these are some additional resources which you should study, and these are apart from ASTO code. There are also as such like as in ACI we have not a single ACI 318. We have multiple supplements of ACI as well. So these are also some additional resources that accompanies the ASTO. So this is the main content of this code. So these are the first chapter is of introduction, and the second is journal design and location features, loads and load factors. The fourth chapter covers structure analysis and evaluation. The fifth chapter covers concrete structures. Sixth is about steel structures, similarly aluminum, wood. Ninth covers the deck and the deck system. So in the relevant lecture, we will refer to the relevant chapter as well. So if you are studying superstructure, so then we will refer to chapter number 5 and chapter number 9. Some references that are very common, then that we will consider, not the whole chapters, because this is a very, you can see a very big, very it has a lot of content, so we cannot cover everything in this you can study for yourself if for some other recommendations. So these are the main um, content of the code. So I think uh, this is enough. We cannot cover this in detail. So as you know that most of you guys are okay. So now it's okay for you. As you know that most of you guys are from Pakistan, and in Pakistan there is a big gap in the bridge design. So the ASHTO LRFD bridge design specification has no official status in Pakistan. So those who use it, they use it on their own discretion. But officially in Pakistan, it does not have any legislation. So the only code that is still used in Pakistan is the West Pakistan Code of Highway Practice. I don't know how many of you know about this code. So this is the official code of Pakistan, and this is a copyright version of ASHTO 64. So this is now ASHTO 2020 has been published, and this in Pakistan we still use this version, which was the uh, uh, adopted from the ASHTO 64 or 65, if I am not wrong, but this is the official code of Pakistan. So you can see that how much lab uh, gap is there in the bridge design in Pakistan. The only thing that we use this code for is the live load models. So it has very good live load models. The only thing this code has is the live load. So when we design bridges, so we only take live load model from this code. So these it has it is an obsolete code. Except for the live load, it it is of no use to the bridge engineers that who are in practice nowadays. So I will show you the live load models. This is one of the live load truck that we use for bridge design. It is known as class A truck. So we just use this code for this live load model, and there is another military class loading. So we use, yes, this. So these apart from these two live load model, we do not use this code anymore in design, because you can you see that this code was published in 1964 and now it is 2022. So many advancement has been done in these years. So this code is no use to us. So I will share both of these codes with you, because you will use the live load models from both from ASHTO and some of the equation from ASHTO and this West Pakistan Code of Highway Practice in the coming lectures. So for the live load modeling. Okay, now I will show you some resources for the drawing. So this is one of the website that is developed by the Communication Works Department of Khyber Pakhtunkhwa. So in this website you can find a lot of drawings, but mostly related to slab bridges and TBM bridges. So this was a project of planning and development department. We did modular design for this project, and is uh, and they have now published it online. So for example, if you want to select, and this is only for Khyber Pakhtunkhwa, so other parts of other provinces of Pakistan, these are not applicable officially, but you can use them, because most of the high seismic zone lies in the KP region. So for example, if you want a modular design for a bridge in Peshawar, so I will select Peshawar. Scour depth, we will discuss this, what scour depth in the foundation, but scour depth is the depth the depth the depth up to which the stream may uh, the scour may affect the stream. So you should keep your foundation below the scour depth, so it does not disturb due to the environmental effect. uh, by selecting scour depth, after then you have to select the span length. So these drawings are available applicable only for span from 10 to 20 meters. So for example, I select span, let's say 18-meter. Abutment height, so these are all site requirements, so these are not any specific requirements. Okay, so soil type C or soil type D, these are based on the code. Okay, foundation, I require deep foundation. For example, I want piles, so number of lanes, I want 2 lanes, number of spans, so you can decide number of spans, but these are simply supported bridges, so they can be used for multiple span as well. A single span design can be used for multiple span as well. So for example, I select 2 spans, skew angle, let's say skew angle is 0, pier height 8 meter is okay, high flat level, so HFL is also one of the factor. MRS year 2022 generate report. So when you, so these are the details which you provide them, then they will they just provide need these details, so they know who are downloading our drawings. So this will generate a barband BOQ for you, the rates and all the and estimates, and here you can find the drawings. So I think this page has been blocked by an extension, I don't know. But I have downloaded a drawing, I will show you how the drawing looks like. So this is a drawing. After selecting all these, you will get one of these drawings. So this is these drawings were prepared by us, so they don't have any highlighted item here. But when you download the drawing from this website, you will find a log. They have a stamped they have stamped these drawings, so nobody can use them for design purpose, but I have the unstamped version. So you check this website yourself. Oh, okay, this is the stamped version. This will be the drawing after you download it from the website. So they have put the stamp so that you cannot use it for official use, but you can use this for a modular design on estimate purpose. So this is I will open the clear version. So this is the drawing. So seismic zone 3, soil type D, foundation type deep. So these are variables you give there, and this you will get this drawing. So the first page is journal notes. So okay, so in the journal notes, all these specifications and requirements are given. So I will share the drawing with you guys, you study it. This is the plan and elevation of the bridge. So this is a typical T-beam bridge, 2-span T-beam bridge. So this is the pier. These are the abutments. Hope you guys see my cursor. These are pier, these are multiple pier. This is known as straddle bend, because if you don't have any restriction on space restriction, so it is recommended that you guys use these multiple column, because this is a very stable system. So if there is no restriction from the side, so we can use multiple piers. This is the plan of the bridge. So this is it has a width of 10.1 meter and 3.95 meter lane, 2 lanes, footpath, and the barriers. These are the abutments. So this is the foundation. These are the piles which are provided beneath the abutments. This is a counterfort type abutment. So this is the main abutment wall, and these are the counterforts. These are the counterfort. This is the typical pile detail. So you see these are the cross section of the piles. As these were modular designs, so depending upon the depth, the span of the bridge, different length of piles and different enforcement configuration were used. Oh, okay. So last time I told you guys that we use mostly we use elastomeric bearing pads. So elastomeric bearing pads, as I told you, is composed of elastomer and steel layer. So this is a typical cross section of elastomeric bearing pad. So you see that we use multiple layers. These are elastomer layers and these are steel layers. And how we decides the number of layers? So mostly the manufacturers have developed their brochures where they have related the depth and the number of layers with the load coming from the superstructure. So when you model the bridge superstructure, you will check the loads coming from the superstructure at these location. So when you get these location loads, the manufacturer will provide you a brochure in which they will have mentioned in which they will have mentioned the bearing size with respect to the loads. So you will decide from the brochure that how much what depth you should decide for the bearing, and how much number of layers of steels and elastomers should be present in your bearing pad. Okay, these are the typical substructure detail, the pile cap beneath the piers. We will discuss these in detail in their subsequent lectures, how we can model it. So I think this is one thing more. So this is we call it in our terms seismic pin or anchor. So these are anchors that are given in the bridges. So the purpose of these anchor is to at one side, let me zoom in so you can see. So these anchor are provided here at both the ends of the girders. So at one end, we the dia of the so how we provide them first. I will show you how we provide them. So this is a typical diaphragm of a bridge. This is the diaphragm. So the purpose of diaphragm is that the deck should behave monolithically, and it also provide lateral stiffness. So we provide diaphragms for the sole purpose of these diaphragm is to stiffen the deck and to provide lateral stability to the bridge. So the bridge deck act as a single structure, because these girders are casted separately. So we connect them by these diaphragms. Hope you guys can see the diaphragms. So diaphragms, multiple diaphragms are provided depending upon span. So at in the mid span and the ends. So you see here at this location, we have provided these pins. So the purpose of these pins is that the bridge should not move excessively in the longitudinal direction, so no deseating occur at the bearing location. The main purpose of these seismic pin is to restrict the longitudinal motion of bridges. You see that we have provided in this design, we did not provided pins here, but sometime we provided pins at both end. So at one end we provide a pin with a larger which are embedded in a larger dia sleeve, and at the other point we provide pin which are embedded in a tight dia, so that it can move freely. You see that we also have provided shear keys. So the purpose of shear keys, let me show you there, shear keys. So the purpose of these shear keys is the lateral statement, so that under earthquake the bridge does not deseat from the bearing pad, because if these superstructure deseat, so the bridge may collapse. And these are very small structure, but they are of excessive important in bridge. So I think this is enough. If I will share these drawings and the code with you. If there is some question, or if you have some problem with the drawing, or if you want to ask something about the drawing, you can ask me in the coming lecture, or we can discuss it on the WhatsApp group as well. So now I will open the software. Hope you guys have the software installed with you. So how many of you have the software installed with you? We have 11 participants. So how many of you have the software, and how many of you are facing problem in installation? In the group there are I think 16 participants, and in the class there are 11. So I don't know why we have very less number of participants in the class. Install on system install. It's my first class. Okay, so okay, I don't know that please In star Dell 377, who is Dell 3537? Please response. Give me response. What is your name? Because here it appears Dell 373537.
It's Fawad Hassan.
Fawad Hassan. So where are you from, Fawad?
I'm basically from Lucky Marwal, but right now in Islamabad, Bahia.
Okay, so you are a professional, working as a professional.
Yes.
Okay. So do you have any previous experience with bridges or not?
No, no.
Okay. So you should, I think, have you, I will add you to the Google Drive and you should watch the yesterday's lecture as well. Okay.
Okay.
All of those who are new to the class, they should send their email in the group. I think you are added to the groups, and after that I will add you to the Google Drive. Then there, from there you can download the there you can see the lectures as well. I will upload today's as well, today's lecture as well. So let me open the CSIBridge software. So this is the CSIBridge software. Okay, and this is our lecture number 2. So let me show you the basic workflow of CSIBridge, and I will open a dual window. So this is how CSIBridge works. If you know the components of the bridge, and uh, then you can, the CSI guys has designed the software GUI of the software such that you can work. If you know the components of the bridge, then you can work it in very smoothly. You will start from the superstructure and then you will proceed toward a substructure. In the same manner you can do it in the software. So the first thing when you open the software is this file. So file, so when you click on file, so here we will have two options, open and new. So if you have previously modeled any, uh, if you have any previous models, then you can start from open, or if you are new, then you start new. So when you click new, the system is, I have opened multiple software at a time, so it's a bit slow. Okay, so when you click new, this window will pop up. So it has two options: initialize model from existing file, initialize model from default setting. Okay, so what is the purpose of this tab, initialize model from existing file? The purpose of this is if you have modeled if you have any previous model and you have defined all the components, all the materials, all the sections, but you are using that section, that material for some other bridge, so you can use this option. So it is a very good option because you don't have to define all the things from zero. If you have previously defined one thing in a model, you can do you can use their data uh, to define a new model, and you have just to define the new layout and the rest of the material will come from that. So let me show you how this works. So I have used initialize model from an existing file. So okay, I will select the blank option. So it will ask me what from which model do you want to initialize your new model. So I will select this model. For example, I select this model. So all these tabs you see have turned now dark. Previously they were. So components are already defined. You can see the materials are already defined. The superstructure section are already defined. So I don't have to define them again and again for new structure. The bearings are already defined. Similarly, loads are already defined. Bridge, only you have to define the bridge object because you have to define the layout line. So the bridge depend upon the layout line. We will discuss this in detail, what is layout line, but Only the layout line you have to define, because every bridge have its own geometry, so the geometry depend upon the layout line. So after selecting a new option, you have only to define the layout line. All the rest of the materials and the section properties are all it has taken from the previous model. So this is the function of this tab. I think I will have to stop the recording because the session is ending in 5 minutes, and we will take a 10 minutes break. Then we will start at 9:40 as 9:40. Then I will show you the next options. So I will stop sharing and we will meet after 10 minutes.